Okay, I'd like to start. So, welcome to lesson 9. The next lecture will be on evaluation, and the lecture after that will be the exam preparation, and it will be already the final lecture of this course. So we're almost there. So this morning was the deadline for assignment 2. My impression when walking around the labs is there was more technical issues with assignment 2 than with assignment 1. Can I get some feedback on what went well and what did not work well for assignment 2? Yeah? Your age exposure request did not seem to work. Not at all? Yeah? Okay, so thanks for the feedback. So what struck me most when I was walking around the different lab rooms is that I got questions from people that got almost to work, right? And needed one little hint in the right direction to make the next step. And I got questions from people that said it doesn't work at all, right? And then when I looked at their code, what I typically saw was a lot of code, right? Where they were unsure of. So there my advice is really take baby steps, right? So make sure if you copy something that you think should work and it doesn't, copy everything out again, add one line at a time, see how it works, see if it works as you expected. Because I have a lot of people, for example, trying to debug functions over and over again, and then in the end they've figured out that the function was never called at all, right? So you're trying to fix something that is not even used at the moment, and then every time you make a change, you're surprised it doesn't work again. So this is a step. So when I, for example, for this function, JavaScript function that should override your submit button, right? I would just call I would make a function submit in JavaScript. So say my submit, right? For lack of a better name. With some parameters, probably event. And I would add one single statement, console log floats my function call or something. Give function and function. Semicolon, I forgot. So when I tried to load this for the first time, right, typically I get an error anyway. Even if it does nothing, I make a typo somewhere. Maybe I don't get any error messages, but I try to do it, and I discovered that nothing is printed on my console log, so something is wrong in registering this handler function to the event. So even before I even can start writing the function, there are so many things that can go wrong, and I want to be sure that all these things are fixed before I try to start with the real coding. Right? And when you're more experienced in JavaScript, you know how to do this, you know how to prevent these errors, right? So you can make bigger steps. But if you're still unsure, I'm not very routine in this, right? And I consider myself to be one of these programmers that doesn't do this type of things often enough to be really prolific in it and make all these things without errors. I always also forget these errors, right? I forget the quotes there, all kinds of stupid mistakes that you can make. So do it really one step at a time. And that tip, I think, was more important for assignment 2 than for assignment 1. It's even more important for assignment 3. So really take baby steps. Okay, other feedback about assignment 2. So one things I noticed when I looked in the Zybook has this functionality where it reports to me the percentage of you that actually did all the participation activities, right? And then for assignment 1, all the HTML and CSS participation activity were really, really high. So I was really pleased with that. And for assignment 2, the basic JavaScript stuff was still quite high. The more advanced became lower. And for the jQuery, it was not even 5%. So for a technology that was so crucial for assignment 2, where it really depended on jQuery, I was a bit disappointed by that. So I think that also comes back to the thing we discussed last week, is how much time should you spend on all this, right? So if you make all the participation activities and you make all the challenge questions, and you start with section 5, then maybe you never make it to section 8. So you need to divide your time strategically over the content and the time that you have, right? So there, maybe it could have helped if you would skip some of the questions in the earlier chapters and make it to the basics of the jQuery section. Because I think most of the assignments, right, they don't require in-depth knowledge, they're just sufficient to make the assignment. Okay. So what I want to do for assignment 3, right? So again, with assignment 3, we're really going from client side or front end to server side or back end. So I really want you to make that switch. And I thought what would be best to do first the content, for example, around Node.js, as in Zybook, or first do the assignment, and I try to do something in the middle. So first do the high level of the assignment, and then do the Node.js, and then come back to the details of the assignment. So that is. So in assignment 1 and 2, right, you have used our server, which by the way was down. Some of you noticed during the weekend that the server went down. I have to admit, I panicked a bit because it's very hard to reach people at system administration in the weekends, right? So I think, okay, if this server stays down until Monday morning, 10 o'clock, then we have a problem. It turned out to be planned maintenance, and people just forgot to communicate that to the users of the systems. So, if I would have known it, right, I could have just warned you that you could not test it between 12 o'clock on Saturday and 2 o'clock on Saturday, and after that everything would work again, but I didn't know. Okay, so there's one lesson learned about the server-side environments, right, because it's not your own computer, it's not your own laptop, it's somebody else's computer, you're always dependent on other parties that host the service. That's also true for a real web server, right? If you're a company, typically you have a hosting provider, an external company that is providing these services to you, and you're dependent on that company. This is also the case here. Okay, so for assignment 3, right, the idea is that you implement more or less the same functionality that our server has, that runs in this web environment from the department, on your own laptop. So you build a little server program that has the same functionality as the one that you have used in assignment 1 and 2. Is that clear on the high level, or is it already? So one of the things you should have noticed is that our server does not provide you with nice, beautiful HTML, CSS web pages, right? It only provides this JSON data output. It also, from the input side, if you send a form or you send an Ajax query to it, you had to send it right in this data format, either the format from your browser when you filled in the form, or JSON in assignment 2. So also for your assignment 3 web service, you can assume that the only input-output is JSON. JSON in, JSON out. So there should be no need in this assignment to do server-side HTML or CSS. So if you're reading about on the web about these template nodes, for example, there's a section in the Zybook on how to do templates, so make HTML out of a database, for example, using JavaScript. It's nice to know, right? But you don't need it for assignment 3. It's only JSON in, JSON out. And then the functions that you need to implement, right, is you need to store your phone data again in the database. So you need to be able to get all the information from the database. You need to be able to add things to the database, to change things, to delete things. And basically, these functions are the same for any database-oriented application. Right? So they've been given names: create, retrieve, update, and delete. CRUD. And this is an acronym that you find a lot in the literature. It's actually also used in the Zybook. But you will also find it in a lot of literature.
Sorry.
Yeah.
Is there ever a circumstance where you wouldn't want to use JSON?
Where you would not?
Would not.
Want to use?
It would be better to use something else.
Is
there a way?
Something else is JSON.
Yeah.
Okay, so the question: are there circumstances where you would use something else? I think the advantage of JSON is that if you're already developing in JavaScript, right, which most web developers on the client side, the front end, are doing, it's really convenient. So if your server side, for example, is not already in JSON, you need to convert it to JSON. So that can be a bottleneck. But I think many data applications on the server side have very good functionality to convert things to JSON. So for all relational databases, it's quite easy. But for example, also graph databases have good conversions to JSON. So I think in a lot of circumstances, JSON is a very good example, target format. So in the morning session, Victor de Boer talked about semantic web data, right, which is really linked data on the web. Also for linked data, there are very good standardized JSON representations. So in my experience, right, it's often just practical. JSON is more practical than other formats. That doesn't mean that other formats are by definition worse. Right? So before JSON became standardized, XML was the norm, and everybody say, okay, why always XML? No, because at that moment it was the most common thing used. So for me, it's more a practical argument than a very principled argument. And if 2 years from now, right, there is another format that even better supported, I will be happy to change this class from JSON to another format. So there are no religious arguments in favor of JSON from my perspective. Does that help? Yeah. Thanks. Thanks for the question. So you have this basic create, retrieve, update, delete functionality. You need to implement that over an HTTP API, right? Because for every function you need to think about, okay, what is the best HTTP message to send from my client to the server to request that function to happen, right? And for most of these functions, this is quite a simple one-to-one mapping from the functionality in the CRUD interface, the CRUD interface, and the HTTP methods. Right, so if you could quickly go through them, add a new phone to your database. What will be the typical HTTP method to use for that? You already did so in your assignment 1 and 2. Post, right? And why post? So one thing that post allows you to do easily is to send data to the server, right? So that makes it easier. If you would use get, then you would need to put all the information that you need in the URI, so you get very long URIs. So that's a practical argument. There's also a principal argument, right? So the idea of get is that you only get information, you don't change anything on the server side. And with post is typically something that you expect something to happen on the server side as well in the data change. Okay. If you want to retrieve data from your database, so either 1 or 3, right? What would be the typical method there? Get, right? This is the prototypical case for get. The last one, delete. It's maybe an HTTP method that you haven't seen, but there is a delete method, right? So here it's simple, delete is delete. And then maybe the only thing that could be a bit debatable is update. So anyone, what would you use for update? If you've read the Zybook, then the answer is literally there. But put, yeah, why put? So put is like a post that you can send data in the body to the database. So that's handy. What is specific about put is that it, if you repeat it 2 times, the effect should be the same as you do it 1 time. Right? So if you say I want to change my the first item of my database value x to y, and then you say it again, change this value to y, you expect nothing to happen. Well, if you say I add an item to the database and then do it again, you would literally add it again. And that if you do it 2 times, only 1 thing happens. That's typical for put. So that if you use put, people would already expect that. But if you add some things 2 times and 2 times the same thing is added to the database, people would expect that with post. So when I say expect, sorry.
What's the difference between the method and the update method? Because I thought when you used update, it would basically take out all the fields that you
Okay, so the question is what's the difference between put and update, right? It's the same thing from 2 different perspectives. So the update is the name for the function in this CRUD speak, so create, retrieve, update, delete, right? And put is the little method that you would use to implement update using the HTTP API. So, so in theory, you can use all these HTTP methods for all these functions. What I'm trying to convey to you is that by using certain functions, you create certain expectations from the developers. So if you would mix them up, right? Technically, if everybody keeps to your conventions, that would still work, but people would expect it in a different way. And a lot of these things are about expectation, right? There is no web police that checks if your retrieve function is actually using get and not something else. But there is an expectation in the developer community that the get would be used typically for retrieve functions and a post to do, for example, creation of items and a delete for deletion. So there's this expectation, and I think it's good that you are aware of the advantages of keeping to these expectations. Makes life simpler. We come back to that later.
There is also
Sorry?
There is, to update, there is also a method patch, right?
PUT, yeah. So PUT, and that's the one I would recommend.
No, I meant
Forget it.
patch.
Patch. Yeah, it's also patch. It's less common, but you could use it. So in practical use, I've never seen this myself, but it is. So if you think there's a good use to it, right? Check the internet semantics. I think if you find other than these common things and you have good reasons to use them, please document them, right? Why you use them, but that's okay. I think it's safer to stick with these common, especially for this create, retrieve, update, delete functions. Right? There is a very well understood set of best practices that use these HTTP methods. Okay, so you use this this HTTP API, and the rules that you need to convey to use. Right? Your server needs to stick to are these RESTful rules. And this notion of REST, I will come back later because that has a very specific semantics. So this part here, I will come back later. So now I want to make sure you understand that like in assignment 1, where there was this strict separation between the HTML and the CSS, right? We had less of that separation in assignment 2. Here, there's a strict separation between the documentation and the implementation. And you can show that you understand the high-level principles of what I've just conveyed, both in the documentation and in the implementation. To the extent that if you would completely miss out on all the implementation, you can still get quite a number of points. Right? So if you're stuck in the implementation part, my advice would be switch to the documentation part, because it can give you a lot of points because you can still document what you were planning to do, right? And make sure that you show that you understood the high-level concepts well enough to have the documentation correct. But also, in my experience, documenting what you are trying to implement really helps also in better understanding what you're trying to implement well it doesn't work. And so sometimes when I start to write the documentation, I realized that I actually did the implementation entirely wrong. And only after writing the documentation, I know what I really should have coded. So here, the advice would be play around a little bit with the code, right? But before you actually start implementing the assignment, do the documentation first, because I think it really helps. And for the implementation, in the previous assignments, the tip was to start from scratch, right? With an empty file and a simple text editor. Here the advice is still to use the simple text editor, but you can use the example code that we have provided as a starting point, just to get you started. And we'll come back to that. So on this high level, are there still questions? And so the one-liner is that for the assignment 3, you need to implement the server that you used so far for assignment 1 and 2. Is that clear? Okay. Now I want to come back to this REST architecture. So we did the client-side part, right? We did from the HTTP part the fact that servers typically either serve static content, so HTML files, CSS files, images, JavaScript files, where the files are just there on the server, and the only task of on the server machine, the only task of the web server is to answer the requests and send the content of these files to the web browser on the other side. Now we're going to do more how to do this dynamic part, and I want to come back to this notion of REST. And also there, I think the principles of REST are really key to the success of the web. And again, I want you to realize that a lot of these big information systems that we have tried to build as humanity, right? So both in the Netherlands, in Europe, internationally, typically they fail, right? And the web is actually one of the examples where something really, really big across organizations, across countries, across cultures actually works. And I think from a technical perspective, all kinds of social and political reasons for that success, but also from a technical perspective. So one, I think, really crucial fact was this, that the entire technical infrastructure of the internet was already there, right? And the things that Tim Berners-Lee needed to add on top of that were relatively small steps, easy to implement. So if the internet wasn't there, Tim Berners-Lee could not have done what he has done. So that's one part. But there are also some rules that the typical web applications implicitly or explicitly adhere to, that make it really simple and really scalable at the same time. And this architecture that really conveys to these web rules is known as REST. And the name comes from this guy. His name is Roy Fielding. He was the co-founder of the Apache Foundation that makes this open source web server, the Apache web server. And he was at the UCI also one of the first PhDs that wrote their PhD thesis about the web. And in this thesis he named these principles that make the web so successful. Already in 2001, I think he was really the first PhD about the web. And he named these principles representational state transfer. And it's grayed out here because you're allowed to forget what it means immediately. Because I don't think it's a very meaningful name. I know very few people for which this name makes sense. But the acronym REST and what it stands for content-wise, you do need to know. And it's a key element of the assignment. So one element is that all the sources of information that we talk about are resources on the web, right? And like every resource, it should have a URI. So you can think of in your assignment 3, right? What are the items in my database and what is their URI? So that would be the first thing to ask yourself. What's the URI? And if you want to operate on these resources, then you need to, as a client and a server, agree upon 3 things. First, of course, the URI itself. So if you want to get the homepage of the department, right, you need to agree on what the homepage of the department's URI is. You need to agree on what are the allowed actions, right? Is only get allowed, or is post also allowed, and add, and patch, and put, and etc. And what are the allowed representations for the client and server to represent this resource in? Right? Do we both agree that we send HTML or GIF or whatever? So these are the 3 things that you need to agree on. And it's basically also the only 3 things that you need to agree on, right? So you don't, as a client, you don't need to know how the server generates the representation. If this is static or dynamic, and if it's done dynamically, if it's done in PHP or in Node.js or on Microsoft Server pages or whatever, you don't, as a client, you don't care. Right? You just want the representation, and the server should generate it, and how the server does its job, you don't care, you don't need to know. And vice versa, right? The server doesn't need to know what you do with it as a client. So if you request an HTML page as a browser to show it to the user, right? That's fine. But if you are requesting an HTML page because you're a web crawler, you want to index it for a server, that's also fine. Server doesn't care, doesn't need to know. It will just do the same thing. It will give you the HTML, and it's as a client, it's your job to do something with it. And if there are intermediate proxies, right? If there is an internet service provider that wants to cache something because it can then reuse it later for other users, both the client and the server don't care and don't need to care, right? So you need to know these 3 things, but it also means that there's a lot of stuff you don't need to know, which makes the whole thing scalable, independent, right? You can change server-side technology without the need to change the client-side technology, etc. And one conceptual thing that makes this easy, that in principle, in this whole architecture, there is no notion of state, which means that one response of one request does not depend on the other. This is not always exactly true. We will come to the exceptions later, but that's the basic principle, right? So, in principle, no state change. So, for example, if you request the homepage of the VU, right, you can do that 1 time, 2 times, 3 times, 100 times. You don't expect that would change anything about this homepage. So the formal way to say this is that the GET method is safe. It has no side effects. You can do it as often as you want to without any harm done. And the POST method should be used when multiple identical requests have different effects, right? Different than a single request. So, for example, if you do a payment, if you do the same payment twice, 2 times the amount of money is transferred, right? Then you would typically use POST. But the POST is really the exception. All the other methods should be what's called idempotent, right? Which means that if you do them multiple times, it should have the same effect as doing them once. So if you would do a financial transfer using PUT, then 2 times the same request, you would expect that the money only transferred once. Right? So if that's not what you want, you should not use PUT. So these notions of safe and idempotent, right, is really important. So get no side effects whatsoever. And if there's a side effect, for example, with PUT, right, there's an update, then the side effect should be only once for the first time. Identical requests should not have other new side effects. So are these terms safe and idempotent clear? So you're expected to use them in your assignment 3, right? Make sure all your GET requests are safe. That if you want to, the effect should be that, that 2 times the same request has 2 times an effect, then you should use POST, etc. Okay, so this, you can understand that if there is no state, right, that really makes things simpler. Because you, it doesn't really matter in what order you do things. You can cache things and without informing the other parties. You can do all kinds of things that makes your life easier. But there are also things that really require state, right, and that makes your life harder. Because then you need to do something extra on top of it that implements these extra features. So the whole discussion about HTTP cookies, right, is about this. Okay, sometimes you really need state. For example, if you want to log in, right, and you don't want to log in every time, then for the next request, you need to know if the user has logged in, yes or no. Which means that your second request depends on the first request. Right, so every time you log in somewhere, you break this basic principle that nothing depends on the previous request, and you need to add something on top of this. For example, by using these cookies. Also, for example, if you have a shopping basket right on your web shop, when you add things to the shopping basket and you want to keep the shopping basket full, then you should go to the shopping basket. The result, of course, depends on what you did previously. So that's also breaking this rule, and you need something like cookies or something else that builds on top of this. If you want to have personal settings, right, and user comes back with the next day, and you want still these settings to be there, you need to recognize the user, you need something extra. So all these things, these can be done, right, but strictly, they don't conform to these REST rules. Doesn't mean it's impossible to do, it's just no longer part of this purely ideal REST world. So typical examples, right? I think we have already seen them. Get for information requests, no side effects. Post for these two identical responses to payments situation. Put for a side effect only once, and then delete also, right? So also once. If you say delete item number 1, and then again you say delete item number 1, then the second time you think, okay, item number 1 was already deleted. Nothing happens. If you say delete the first item that you encounter in the database, right, that would not be strictly a RESTful operation, because then the second delete would do the deletion of the next item in the database. So then 2 times the delete on the same URL. My example.org/first would have 2 times a different request. So a true RESTful developer would never design that kind of API. Right? It's not impossible to do, but if you do it, it would not be called RESTful. And a lot of web developers expect your API to be RESTful. So this would not be best practices. Now this, all these rules, right? They apply to getting and updating and deleting HTML pages, right? But in practice, it's most often used in this data context that we also deal with in assignment 3. So it is used for organizations that provide web services to other websites. So the typical situation here is that you as a service, right, you provide this HTTP API to people that want to develop web applications using your data. And I want to give you an example of 2 real-world applications, right? So one is the Spotify API. So the Spotify API is an API that is really inspired on these RESTful principles, right? Of course, also Spotify needs to log in and authenticate, and so that part is built on top of that. But the basic API is based on simple REST principles, and they even say so themselves. So one of the things that Spotify wants is that other people build applications on top of their data, right? That's part of their business model. So they don't want to hide this, they want to stimulate as many developers as possible to use this. So for example, if you, as a newspaper, right, provide a newspaper article online that talks about a new song of a new artist, they like the newspaper to include a Spotify link, right, using this API to that song. Or if you have a playlist, right, you can have the whole playlist in your own web environment. So this API allows you to do that, and it allows, for example, content provider, software content providers, right, like blog software, to make this really easy. So the more people that use this, the better it is for Spotify. So to make this simple, right, they conform to all these REST API principles, because by doing so, they make it easier for the developers that already know these principles. So the request methods they use, right, are these same get, post, put, delete that we just saw, right? And because they use get where people expect get, and they use delete where people expect delete, they don't even need to document this full, because people will just guess that this is the case. So this makes this allows you to actually develop these web applications without studying the manual in depth, because by just guessing, you can get a long way. Now they need, of course, to agree on these URIs, right? So there's a whole scheme on how to make these URIs that Spotify will recognize. So this is the part of, you need to agree on your URIs and on your IDs. And the URI that you use for these services, right? So that was the WT FEV.3.nl. There was a lot somewhere. Okay. /API 20, right? / some key that you used for assignment 1 and 2, right? In this this would be a web endpoint. So every time you see this term web endpoint, they refer to a URI like this that you can use to get JSON data or to store JSON data, etc. And of course, for every request, right, you get a response back as a web developer, and you also need to understand how this response looks like. So they have a lot of documentation on how to do that. They will sometimes have examples of command line applications that you can use to test this. Right? So curl is a open source command line application that's available on most machines that you can use to send all kinds of HTTP requests to a server. They give examples of that. You can use the same for your documentation in assignment 3, right? We've looked at these response codes earlier, right? That every HTTP request comes with a response, and every response in the first line has a response code to tell the client quickly how successful his request was. And they completely document for each response code that they used in the API what the meaning of this is. Now they do it once for the entire website, right? Which means that they cannot be very specific. What I want you to do is to do this for every one of these 5 operations. Right? So the 5 operations that you have in the assignment. So, for example, retrieve all the data in the database. So, what are the response codes that a developer can expect? Right? Hopefully, you will get some 200 response if everything goes right. But what are the other ones? What can go wrong? And what response codes can you expect? Now, this goes on and on. What I want you to use this for as inspiration, right? What kind of things can you document? And this is a long website because they have hundreds and hundreds of methods, right? You need only 5, so yours will be much shorter and much simpler. But use this as inspiration. And to make sure that you don't think I have shares in Spotify, this is a similar page for the Twitter RESTful API. Right? And many of these big tech companies nowadays have APIs like this. Right? Usually we will see the same things. So these are the GET and the POST requests that Twitter supports. Right? So these are the short versions of the URIs. So probably you will need to add like https://twitter.com in front of this, and then comes this. And this goes on and on for all the things they support. And if you want to have more details, right, you can go to the different options. So this is the full API. This is the format. So they also use JSON. That goes on and on. I want to the parameters you can give. So this is an example request, right, in HTTP, and this is an example response. So you will see this is JSON data. This is also, I think, very typical for these web API documentations. Right? Just give an example of a request, give an example of a response, and if the example is like self-explanatory, you need only very little text to document your services, right? And put you in the mind of a web developer. They typically like these short examples over long pieces of text. So this is a hint for the documentation part. I want to leave it like here for the break. So let's do a 15-minute break, and then after the break we'll come back to the more nitty-gritty details of how to do the implementation in Node.js. Okay, thanks.
I left a message in